Alright, students, in this video I'm going to go over a short summary of 8.6 notes. So this is similar to 8.5. The only difference is that this is exponential and these are logarithm equations. So on 8.5 we went from exponential to logarithms. Now we're going to go backwards. We're going to have logs and we need to use rewriting it as exponential to be able to solve it. Still using PEMDAS backwards. So let's go ahead and do the examples. I'm going to go over the 3 examples on the left side. So we're going to start by recognizing that the log with the argument of x minus 5 needs to be isolated. So we need to get rid of the 3 in the front. That 3 is multiplying times the log right now, so we're going to divide by 3. Notice that there's no plus or minus outside of the log, so we can skip that and then just go into multiplying or dividing. So this will cancel the 3 in the front, and then now you have log x minus 5 equals 2. So when we don't have anything else other than log, we're going to go ahead and reverse the log because we want to get it in there and solve for x. So in order to get inside the argument, we need to undo the log. So we start by recognizing the base, and we recall that in 8.2, we have 3 types of bases, which is numbers, a base of 10, or a base of e. And we will either have log with a base, or log without a number, or ln. In this case, we have log without a number, which means that the base is 10. If we have ln, our base will be e. So just keep that in mind for the examples that we're doing. So again, we notice there's no base, which means we have a little secret base of 10. So we're going to write down the base of 10, and then we're going to switch these 2 parts. So we're going to have the 2 first as an exponent, and then it equals the argument of x minus 5. So that's the rewriting process. We keep the base and switch the parts that we see right here, the argument and then the equals. So this right here can get us almost to the answer. We just got to isolate for x. That minus 5 next to the x needs to be canceled. So to cancel minus 5, we're going to add 5. And we have 10 to the second power plus 5. So again, this stays together. We don't add these 2 together. And this should give us our x value. So 10 squared plus 5, if you have a calculator, you will just type that together. 10 squared plus 5, and then that's 105. So 105 equals x. Let's try another. Here we have a log base of 3, x plus 11 as an argument, so this is together. And then notice that there's a minus 10 after that. So this minus 10 needs to disappear by adding 10 to both sides. And now we have log base 3, x plus 11 equals positive 4. Once we get there, we are going to now recognize that we need to undo the log because we want to get to the x inside the argument. So the base is 3. We're going to write 3. And then these 2 are going to switch. So we're going to put the 4 as an exponent and then x plus 11 after the equal sign. So we're going to solve for x. That means we're going to get rid of positive 11. So negative 11 will cancel that. So we're going to write minus 11 on this side. And this is together. So we're going to have 3 to the 4th power minus 11 equals x. And then you just type that in your calculator. So 3 to the 4th power minus 11, it's a 70. So we're going to have 70 equals x. All right. One more problem here. We have ln, natural log. So we're trying to isolate the natural log with the argument of x plus 4. And we have a negative in the front and a plus 9 after. So following PEMDAS, we are going to do adding and subtracting first because we're going backwards. So this has to cancel. Minus 9 minus 9. That cancels and we're left with negative ln x plus 4 equals positive 3. And then we need to get rid of that coefficient of negative in the front by multiplying or dividing. So when there's no number, it's technically a -1. So we can divide by -1 or multiply by -1, whichever one you prefer. So that cancels the negative, and you're left with natural log of x plus 4 equals -3. And then here we want to get inside the parentheses to get the x by itself. So we need to undo the natural log. And once again, back to the 8.2 notes, natural logs are the inverse of e. So since we are writing our base is e in this case. And the exponent that we write next to e is this one, because we're going to switch these. We're going to flip them. So this is -3 as an exponent, and then it equals x plus 4. Alright, once you get there, we want to solve for x, so we need to get rid of the -4, or the +4, by subtracting 4. And this stays together, so we're going to have e to the -3rd power minus 4 equals x. So you're going to type in your calculator, e to the -3rd power minus 4. So that is -3.95. -3.95 equals x. So that's how you solve equations. I encourage you to do the 3 problems on the right side and check your answers on Schoology.